Before starting to solve this question, stop the movie and read it. Then start the movie again and we'll go through the differences between questions A, B, and C. It is very important to visualize what we are asked. So if this is, all of these three are clones of the normal distribution with the mean 330 and the standard deviation 8. So the variance is 8 squared. First question asks, find the probability that the tin contains less than 320. So 320, my diagrams are not to scale, but I try to be as accurate as I can. 320 is below the mean, 330, so it will be somewhere here. So my question A, the question A actually asks about this area, where here we have 320. Question B, what probability contains between 320 and 345? So I'm asked about this area. And question C asks, what volume is exceeded by 5% of the tin? So basically we are asked about the top 5%. So I'm giving this area this time. I know that this is 5% and I need to find this point. Whereas in the other cases, I need to find areas. So see how these questions are different. Now, when I looked at question B, I thought immediately that could have been a very interesting question. So let me bring another diagram here. If they asked, in question B, if they asked, okay, in question B, I thought, okay, this one is 320, so I'm asked about 320 to 345. So I thought for a moment, the mean is 330. I thought for a moment, oh, if they asked me from 320 to 340, but unfortunately, no, they didn't. If they ask me that, see how this is symmetric. And from question A, I know this area. Let me call it A, whatever. It's my answer in question A. And I would know that the probability from minus infinity to 330 is 50%. So this one will be 50% minus A, because see, the whole thing here is 50%. And this one will be the same, 0.5 minus what is your answer in A. So therefore, if the question asks what's the probability of X being between 320 and 340, my answer would have been 1 minus 2A, where A is my answer in question A. But I'm not that lucky, so I need to do some calculations. Just what I wanted to point out is that while I'm drawing this, I'm doing some thinking of how the questions are related to each other, and very often they are. Now, we did previously quite a bit of work on how to find probabilities, and that would be the answers. Please check them. In question C, we have X, which is normally distributed, and we do not know the mean, mu, but we know that the standard deviation is still 8. We know that only 5% are below 320. So if this will be 320, we know that 5% would be here. Probably 320 is a bit to the left, if I'm to be more accurate, because this looks more than 5%. With this information, I'm asked to find the mean. So I cannot use a calculator anymore, and I need to standardize. Whenever I don't know the mean, I need to standardize, because for the standard deviation, for the standard distribution Z, I know the mean and the standard deviation. What links the two distributions is that if I'm looking at the same left 5%, I can find the point here using a table of values or my calculator. Let me call it Z. And I know that if this is X, Z and X are linked by the formula Z equals X minus mu over sigma. So in this formula now, I would know Z from here because I know everything from this distribution. I know X. I want to connect these 2 points. I know sigma, it's 8, and I don't know mu, so I have an equation where I can find mu. Now I need either to use a table of values or my calculator to find this point here. So this question C is similar to the question C here, when you know the percentage, the area, and you need to find a point. So if you look at your formal booklet, 5% to the left is the same as looking at, that's a faster way probably to do it. It's the same way as, is the same almost as looking at 95% here on the same Z distribution. So 95% gives me 1.645. And then I know that the 5% to the left gives me a point that is symmetric to this one by the mean. But in the case of normal distributed with 0, 1 squared, the mean is 0. So this point will be minus 1.645. That's why going back, Z in this case is minus 1.645. So minus 1.645 equals X minus mu over sigma. Solving this equation, I find mu. And mu will give me 3.16, so 333 milliliters with 3 significant figures. Question E, it's exactly the same, it's absolutely the same idea, but in question C, you are given the mean, you are given a condition, and you are asked to find the standard deviation. So let's do this question now. We know that the same 5% stay below 320. We have the same distribution, or the same shape actually. We know the mean, but we don't know the standard deviation. So practically the same. It's normal distribution, but it's the same. When I standardize, because I have 5% here, I'll have the same z-score, minus 1.645. So in this case, my equation will be minus 1.645 equals X minus mu. Now I don't know mu. Minus 330, now I know the mu, over sigma, and I don't know the sigma. So I'll find the sigma, which will give me sigma 6.07902, so 6.08 to 3 significant figures. Please note that standard deviation always needs to be positive. If you get a negative value, then you have an error somewhere. I like this problem because includes through all the 5 sub-questions all the skills that I need for normal distribution. There are practically all types of problems with normal distributions are hidden in this question. We are going to solve together a few questions on normal distribution and how we apply it in real-life situations. Please stop the movie and try the question by yourself. First step, I'm going to read the question and map the information given into a mathematical model. So I see we have a normal distribution with the mean and the variance that are given. Therefore, I will say that L is normally distributed with a mean 15.85 and the variance 0.36, so that's 0.6 squared. I like to write it always this way so that I remember that this is the standard deviation. For a jump chosen at random, find the probability that the jump is at least 16.2. So I am asked to find probability that L is bigger than 16.2. I will need to standardize the normal variable. So I will use Z, which is normally distributed with 0, 1. This is because I have a table of values for Z, but I can't have table of values for each possible normal distribution. So this is Z and this is L.
I'm interested in probability of L is bigger than 16.2. So I'm interested in this area. And I know that I can find probabilities on the standard normal distribution. And I know that this Z is connected by this L, or in your formula booklet is called X, by the formula Z equals X minus mu over sigma. Therefore, I'm going to find Z there, and Z is X minus mu over sigma, 0.6. See, when it is very useful to write sigma in this way, or the variance, so that I can see immediately sigma. So my answer here is 7 over 12, or 0.58333, or 3 recurring. Now I need to find on this distribution probability of Z being bigger than 0.58333 recurring. And either I have a calculator, which is very useful. If no, I'm going to use a table of values. If I am to use a table of values and not a calculator, please be mindful that the values are for the area to the left. So whatever I find is going to bring me the blue area. So I'm going to find probability of Z being smaller than 0.5833. And then to find the area that I'm asked, I need to subtract this one from 1. So let's look for 0.583. So 0.58 is 0.7190, and then I need to continue to look for the line with a 3. So I have to add a 10. So I add a 10, and I get 0.720. Therefore, this area is 0.720. So the area that I'm asking question A, which is probability of Z bigger than 0.583, is 1 minus the answer above, so it's 0.280 to 3 significant figures. Let us remember that we are asked to calculate this area on the distribution of L, but it's the same as the area here. Therefore, this is my answer. This method might seem a bit long. People are used to a method that works at the basic levels. I prefer to use this method because I can extend it. Whenever the question is different, I can still solve it if I understand the good relationship between these two distributions. And I'm starting in example 1 with easy examples, and towards the end you'll see examples where actually this knowledge is needed to solve the last questions, because those will be in unfamiliar situations. So the method that people prefer, and I see it very often, is this method is absolutely correct as long as you connect it back to what I explained before. So don't forget how to connect it back, because actually for different difficult questions, this is a method that is going to help you. Let's look at question B. In the competition, there is a qualifying distance of 16.2. Find the probability that he jumps over 16.5, given that he makes a qualifying distance with a jump. So given that L is bigger than 16.2. So with this, we remember the conditional probability. I apply the formula. That's probability of L bigger than 16.5 and L is bigger than 16.2 over probability of L bigger than 16.2. And if I enter the same time for L to be bigger than 16.5 and 16.2, I'm left with L bigger than 16.5 over probability of L bigger than 16.2. To save our time, very often one of these has been calculated before, so I'm going to check, and I see indeed the denominator was calculated in question A, So the denominator is 0.280. So I'm left just to calculate probability of L being bigger than 16.5. I apply a procedure similar to the one above, and I find 0.1393 over 0.280, which gives me 0.480 to three significant figures. Let us look at this question. The time t taken for the employees of a large firm to travel to work can be assumed to be normally distributed. Of the employees, 10% take at least 40 minutes to travel. So if you imagine the normal distribution, 10% take 40 minutes or less, or more, at least 40 minutes. So this will be 10% of your employees. So probability of t being bigger than 40 is 0.1. 0.5% take less than 8 minutes. So if here it's 8 minutes, here you have the 0.85% of your employees. So probability of t smaller than 8 is 0.05. And find the mean and standard deviation. So this is a problem when I don't know the mean and the standard deviation. So the only thing I can do is to rely at standardized normal. So that's my z distribution, standard normal distribution, and that was my t, normally with mu sigma square, which I don't know, so actually I'm just drawing, but I'm not very sure. The shape will be always the same, but I'm not sure if the standard deviation is smaller or bigger, if the mean is to the left or to the right. So how do I rely to the standard normal distribution? I know that the area preserves. So if I have here 0.5%, I can find the point here. And I know that these 2 points will be related, if this one is z and this one is x, will be related by the formula z equals x minus mu over sigma. So that will give me an equation in mu and sigma. And that's what I'm going to do for the next point. So this is the second z that marks you 10% to the right. Therefore, for this z will be related to the number 40 by the same equation. So I'm going to look at the standardized normal to find the point here and the point here. If I have a calculator, that's very easy. It will take me 5-7 seconds just to input in my calculator. If I don't have, then I'm going to use a table of values, which I'm going to bring here. Again, if you have a calculator, you can skip the steps from now. I'm looking for the area to the left of 0.5% first in order to find this point here. But if you look in my table of values, all areas start from 50% or above. So what I need to do, I need to imagine how, if I want the point here for the standardized normal, z, the mean is 0. So if I want the point here, which splits you, which divides an area of 0.5%, then I can find the point which is opposite to it on the other side, so such that this area is 0.5%. Therefore, I can find this point because in my table of values, if you look, there are only points that are to the right of 0. So to find that point, as I did before, I will look at this area, the whole area, and this whole area will be 100% minus 5%. So it's 0.5%. So let's take 1 minus 0.005. So it's 0.995. Now I'm lucky to recognize that this is one number, that it's a critical value, is very often met, so I'll find it here. And the number is 2.576. So I will use this value here, 2.576. So this point is actually negative 2.576. Now I'm going to look to the other point here. And for it, the area to the left is 90%. And it's easy because that's a value that is my table again. So for an area of 90%, which is here, I have 1.282. So this point here will be 1.282. In fact, with this question, in either they don't want to check that I know how to use a table of value or the calculator. That's why they give me some nice numbers. Now let's go back to my problem. Remember what I wanted to find. I wanted to find mu and sigma. So this z here is related to this 8 here by the formula z equals x minus mu, which I don't know, over sigma. And the point here is related to the one here by the formula 1.282 equals x minus mu over sigma. So I have simultaneous equations in mu and sigma. Therefore, I'm going to solve this system. I would say that not in all cases such a model can be estimated by a normal distribution. And that's because in this normal distribution, we'd assume that the majority of the people live within, if this is a business, if this is the office, live within a certain distance from the office. And there are just a few ones who live close to the office, and there will be the ones on the left-hand side. And there will be a few going outside very far from the office, and this will be the ones on the left-hand side. So it depends all on the firm and where the people live. Also, it might happen that depends on the different times of the day, we can have different traffic. So this can also influence the shape of my distribution. One thing that it is very important to consider is that in a normal distribution, the values of x can be negative as well. And for our case, it's not realistic to have negative times. However, if you look at the mean of the normal distribution, which is, in my case, 29, so almost 30 minutes, and the standard deviation is 8, within 3 standard deviations, we are left with a very small number of values. And within 3 standard deviation will take you just about 0. So overall, it depends, but it can be, in certain conditions, a good model. On the next pages, we are going to look at 4 questions from past papers. So I would suggest to stop the movie and try the question by yourself first. Then you can look at the marking scheme. As you see, the marking scheme, or the solution given in the marking scheme, it's very minimal. In fact, that's why it's called marking scheme, because it's not a full solution. What I recommend you is to draw a diagram and try to make sense of the problem. Write the diagram on your paper, same as we've done in the previous question. This can be your method as well. When you read the question, rewrite this one in the form that will help you. So rewrite normal distribution of 20 and 7 squared. In this way, when I work with my calculator, I'll see that the standard deviation is 7. Under the exam conditions, students very often look at here and don't remember when is standard deviation, when is variance, so they will put here 49 by mistake. That's one of the common occurring mistakes. So follow all the good practices that we showed in the first 3 questions. Please pause the movie and try the question by yourself. I will add the marking scheme now. Here is the marking scheme for you to check your answers. Here is our next question. Stop the movie and try it. And this is your marking scheme. Please try to use the good notations you used before. So when you read the question, the time taken to cook an egg, so x is the time taken, and x is normally distributed with 4.2,
and 0.6 squared. Write down that. You don't want during the solving the question to go back and read and start looking through the text, which is your mean and which is your standard deviation. Also, I advise you to write X is time to cook an egg. Why we do this, that's good habit, because later on, especially in S2, we will have more than one distribution in a question. So therefore, we'll need to know what distribution we are talking about. Also, I never write this. That's just for the purposes of this marking scheme. So what we write is probability of X smaller than 4.5. Even if you read that, see, it doesn't make sense. Probability of smaller than 4.5, what? But they didn't write X. I repeat, because it's just a marking scheme. It is not a full solution. And here is the last question to try. Stop the movie and try it. This is a marking scheme for your last question in this movie.